Today we are going to have a look at Pythagorean triads. Now, a Pythagorean triad is a special term for a group of three numbers that satisfy Pythagoras' theorem. So what that means, if ABC, so throw in any three numbers there, is a Pythagorean triad, that means that c squared is equal to a squared plus b squared. So what we'll find, if we have a group of three numbers, if we put them into Pythagoras' theorem, the left side will come out to be equal to the right-hand side. Okay, so what that means is any multiple of our three numbers that do satisfy Pythagoras' theorem and are in fact a Pythagorean triad, that's also a Pythagorean triad. So say your most basic Pythagorean triad that probably we all know by now is 3, 4, 5. So the two shorter sides are 3 and 4, and the hypotenuse is 5. What that means is any multiple of 3, 4, and 5 is also a Pythagorean triad. Okay? So we can actually use Pythagoras' theorem to test whether a group of three numbers is in fact a Pythagorean triad or not. So we're going to do that with 5, 12, and 13. Okay, so obviously 13 is going to be represented by C because it's the largest number. Okay, and the other two can be A and B. It doesn't really matter about those as long as you can identify what would be the hypotenuse out of the group of three. Okay, so we know that Pythagoras' theorem states that C squared is equal to A squared plus B squared. In this case, C we have said is 13, so 13 squared is equal to 5 squared plus 12 squared. 13 squared is 169. 5 squared is 25. 12 squared is 144. 25 plus 144 does in fact equal 169. So what we say, if we had more room, I didn't leave myself enough, we say that left-hand side, LHS, is equal to right-hand side, or RHS. Therefore, now we write out our set of numbers again, 5, 12, 13 is a Pythagorean triad. Okay, so whenever you're asked to test something like this, you need to be clear about your result. Don't leave it here, okay, because you need to show that you understand what it is you have been asked. You were asked whether these three numbers are a Pythagorean triad. So this is your working out, this is your answer. Because the left-hand side is equal to the right-hand side, that means that 5, 12, 13 is in fact a Pythagorean triad. Okay, so don't be tempted to finish your answer early or you won't get rewarded for it in terms of marks. Okay, so then just another little question you may be asked. As I mentioned before, 3, 4, 5 is a Pythagorean triad. We can use that to create others by multiplying by whatever number. So I've just given you a few here. So 2, 9, and a half, and we'll use those to show more Pythagorean triads. Okay, so if we multiply each of the values in the triad by 2, that's going to give us another triad. So 3 times 2 gives us 6. 4 times 2 gives us 8. 5 times 2 gives us 10. Okay, so 6, that means that 6, 8, 10 is also a Pythagorean triad. Okay, if we multiply each of the values in our original triad by 9, we'll create another one. So 3 times 9 is 27. 4 times 9 is 36. 5 times 9 is 45. So that means that 27, 36, 45 is another Pythagorean triad. Okay, if we multiply each of our original values, 3, 4, 5, by a half, we'll create another Pythagorean triad. 3 times a half is 1.5. Remember, 3 times a half is another way of saying half of 3. Okay, 4 times a half is 2. 5 times a half is 2.5. Now, don't be worried about these not being whole numbers, okay? We know that triangles aren't always... triangles don't always have perfect whole number lengths, and that is absolutely okay. So whether or not they're whole numbers, it still creates a Pythagorean triad as long as it satisfies Pythagoras' theorem or it is a multiple of a set of numbers that you know does. Hopefully that was really helpful for you. Give us a thumbs up if it was, and don't forget to subscribe so you get notified when I upload new videos.